Domingos Barbosa. Domingos is a senior researcher with the Instituto Telecomunications and the coordinator of the National Research Infrastructure of Strategic Relevance ArraySKA that supports Portuguese participation in the Square Kilometre Array. Domingos, the floor is yours.
Thank you. Can you hear me well?
Yes, very well.
Yes. So I will share my presentation, and hopefully I will ask at slide 7 for the regie to pass the short 1-minute video that I sent the link before. Okay.
Okay.
Okay. Let me see. Okay, can you see my presentation?
Yes, we have your presentation now.
Okay, so here we go. First of all, thank you very much for the kind invitation, and I would like to warmly thank José Borrego and José Barros for all the help and all the visibility that is providing to the Square Kilometre Array. And in fact, Square Kilometre Array is a data machine in the Atlantic, or most of it in the Atlantic. So the Square Kilometre Array essentially is a gigantic radio telescope that will be installed in the Southern Hemisphere in 2 continents, South Africa and Australia. The phase 1 is set up to start by July this year, and it will be composed of about 200 antennas of 15 diameter dishes in South Africa, and about 130 dipole antennas in Australia, spread across an areas of about 200 kilometers each, and with a few isolated stations outwards. In the phase 2, after 2025, it will spread over the neighboring countries. Of course, in Australia, it will encompass all of Australia, and in Africa, it will go to Zambia, Mauritius, Namibia, and countries like Mozambique, which will have more radio telescopes, and Portugal will have probably. So the cost cap for the construction of the SKA, it will be between 800 and 900 million euros, with a total budget, including operational costs for the first few years of 1.5 billion. So it's really a remarkable project in terms of sizing. There is already a lot of things happening, and of course, in South Africa in particular, since we are in the Atlantic, there are already 64 antennas of the Meerkat precursor installed. It's operational, and these 64 antennas are already the most sensitive radio telescope in the world. So South Africa really came to the first stage of the world science. And you'll see that in particular, there is world-class, Nobel-class science to emerge, being produced in Africa for the next 2 or 3 decades to come. In terms of Portuguese engagement, so we were awarded a grant of about 4 million euros in 2017. We were included in the national roadmap of research infrastructures. And of course, big steps forward came about in 2019 when the Minister of Science signed the memorandum for Portugal to become member of the SKA. Last year, in 2020, in November, the Portuguese Parliament ratified the decision of the minister, and in 2021, Portugal actually concluded the process and became a founding member of the SKA Observatory, a new international organization, to become most likely one of the largest science organizations and infrastructures in the world for the next 30 to 40 to 50 years. In terms of data, SKA has been duly identified as a data machine. So the antennas will produce something like raw data of about the petabyte per second raw data outputs. It will be pre-processed locally and hugely compressed, hopefully, to about a few terabits per second. And it is all this in a few scale of the nodes of a few kilometers. Then the major nodes will throw the data to the science data processors, huge supercomputers to be located in Cape Town in South Africa and in Perth in Australia, of about 130 petabytes, petaflops of processing capacity. And essentially in the end, we have about 600 petabytes of data flowing around these two production sites in South Africa and Australia to the network of data centers that will explore science around the world. Europe is one of the regions that will have a full copy of the data processed in South Africa and Australia. So we expect about 600 petabytes of data a year. So if you compare to the uploads to Facebook, which is about less than 200 petabytes a year, so it's really huge. So can you pass the video, please?
Okay. We are waiting. Okay, there it is.
Yes, probably I have to stop share for the moment for you to share the video.
Okay, it's okay, Domingos. We are seeing the video. Do you want to comment the images?
Yes. So essentially, what you're seeing is the same thing as the data flow of the SKA, and you see that the radio waves are collected by the receivers, and they are processed. They are sent to about 100,000 kilometers of fiber, going to a central processor, which essentially correlates the data and tags the data with time, coordinates, and a whole bunch of things, filters things out, and throws the data to the science data processors. This goes also around, and it will provide science visions on a number of very important science cases, and will produce what we call data cubes, which are images that are with very deep in the sky, with a lot of distances, or redshifts, as we say in astronomy, billions of objects, and then this goes to a number of science regional data centers spread around the world. And so these 600 petabytes of data will really be a cumulative data, which is actually quite a large challenge for the present community. And so we have to work hand in hand with the NRENs, like FCCN here present, and the operators and the regulators to ensure that we have an optimal science output. Sorry. Okay, so in terms of the data flow, the data flow from South Africa will flow through submarine cables, as you might see, and then of course most of these configuration, science requirements, user requirements, and operational requirements were set up by a number of institutions and NRENs working together to design the Federated European SKA Regional Center. Was funded through Horizon 2020 and essentially mapped the existing facilities, mapped the current roadmaps, and made some prototyping studies of storage, processing, and connectivity. And for instance, forget about the science cases that is on the bottom of my slide. What's important here is to understand it's what we have here is that we have about 750 petabytes per year for the first 10 years, or essentially about 9 exabytes over the course of the first 15 years of operation. And so it's really huge stress in terms of digital infrastructure in Europe. In terms of connectivity, the studies were made with existing cables, which this study was made before the Eurolink came to life, and I think they will have to be updated to include Eurolink. And so, for example, the price of connectivity between Cape Town and Europe and Portugal and London, it's about $1 million a year of costs. And this is quite significant. And of course, this was considering the WACS and the CCOM cables, which have limited bandwidth, and of course, are approaching their service end of life or probably needing some upgrades. So the interceptions of Eurolink further north above the equator will be really an important step to consider for these studies. In terms of the connectivity that we are considering for the SKA, for example, and the interconnectivity between South Africa and Australia, because there are science data products that have to be interchanged, processed in other sites, and then redone and resent again. We had considered for South Africa the 5 flows on submarine cables from Cape Town to London before they joined the IP network. And then it connects with different cables reaching India, Australia, and Europe. The same for SKA Low Australia. Of course, the main cable will be from Perth to Singapore, then it spreads over to the other regions in the world. In terms of what we are considering in Europe, of course, everything will be modulated by GEANT Europe, of course, and then the countries that will subscribe the constitutions of SKA regional science center in their countries will have to sit and negotiate with the NRENs and have an agreement with GEANT how to serve the SKA purposes, how to serve communities. But since some communities will not be big enough, but they have resources to provide, there will be an important aspect of data curation facilities to be provided to the global scientific community for the first 10 to 20 years. And this is a very important discussion that is actually taking place now. And the final requirements and the final proposition will be probably finalized within 2 years. And let me tell you that with these 700 to 800 petabytes a year being produced after 2024, 25, and with Africa emerging to the world science stage with Nobel class science, we have to say that this Africa is really rising. We have to be aware Africa will provide not only from the oil and gas perspective and natural resources, will provide huge data, loads of information comparable to other regions in the world. And so I have to remember that these ANACOM had set up the stage for these discussions at European level already in 2012, and they supported quite a bit. And so it's a pleasure to be almost 10 years later, and we're discussing the follow-ups and seeing that many things that were advocated in 2012 as possible are now a reality. So thank you so much, and muito obrigado.
Thank you very much, Domingos. In fact, I have a question. Can SKA become a cornerstone data user of the Atlantic infrastructure, and will it require dedicated fiber channels?
Yes. SKA will become a cornerstone digital infrastructure of the Atlantic. It will also require a dedicated pairs of channels within the existing submarine cables, and most likely we will be one of the key clients for any future cable or cable reinforcements for the next decades. So count with SKA to be an active part of this Atlantic infrastructure design.
Okay, thank you so much, Domingos.